Let's start. So in the last session, what we have seen, we briefly talked about your AWS basics and your regions, availability zones, right? And where we should start learning our AWS journey, right? And we have listed out the hierarchy of the topics what we're going to cover going forward, right? So part of that today, what we will do, we'll start with AWS networking. Okay, so within that, we'll talk about few components, which is VPC, virtual private cloud, right? Subnets, and then route tables, right? Internet gateway, and then have security groups, network access control list, NACL, clearly. Okay, and what else? Right, now for basic start, right? Let's start with this, and we do have a couple of more components, right? So that we will add on top of this as again, so as long as we complete the testing, I will add the other stuff. So let's go to VPC on my management console, right? So these are the options I'm talking about. Now, before we go ahead and talk about anything as such networking, one thing what we need to discuss is your console. Right. So when you log in into AWS default homepage, right, you will see console home region is US East 1. By default, it is always set to US East 1. If you want to deploy something in Mumbai, you need to select, then region will become AP South 1, right? So in short, what we have here, for every region, the URL is changing a little bit. Okay, so if you see the URL apsouth1.console.aws.com. Now, if I change it to North Virginia, simple console.aws.com, aws.amazon.com. There is no region associated in front, but if I select any other region, you will see a region is displayed here. Okay, so one advantage or one disadvantage. So advantage is, let's say, if there is an issue on accessing this console, only one region console will be down. Rest all at least should work because each and every region has its own console, right? So it will not impact other regions if one console is having an issue. So there is one advantage. And a disadvantage point of view, you have to give up permissions, or you have to let's say whitelist URLs. Okay, if in your organizations you have a security standards enabled and other stuff, you need to enable all these URLs. Okay, star.console.aws.com. Okay, I don't see that as a disadvantage, but in terms of administration from your local firewall point of view, you need to allow these things. But and apart from all these, let's say if I select billing, there is billing. Let's search for billing. If I go to billing, irrespective of where you are, you will see it is set to global. Okay, so far, you'll see all are grayed out, and you'll see blue, right? So some of the components are global components. Right? Some of the components are global components. One of the component is your billing services is global. Right? Any other service? Let's say Route 53. See, Route 53 is also global DNS, global DNS. Right? Again, you have few services which are really global services. You don't need to specify any region for that. Okay. Other than that, if you see network or storage or EC2 or your Lambda functions or databases, any sort of any sort of component which is bounded with data. Okay, you are storing some data somewhere that needs a region. Okay, now DNS and all is just DNS entries. Okay, they can replicate across the globe. If one of the region is down, don't worry, we have other 25-30 regions available. We will run the DNS services from there. So that's the reason you'll see some of these services mentioned as global. Okay, in short, we have region services and then global services. That is one point. Second point is, for every specific region, you'll have individual consoles. Okay, um, that's about your console. Now moving on to your networking side. So the first and foremost component will come into picture is your VPC. Okay, so what is this VPC? Let's say in your traditional way, if you want to configure something or if you want to build a network, what you will do? I'm talking about your on-premise traditional network. Okay, you have, say, let's consider office. An office somewhere in the corner room, you'll have somewhere in extreme corner or a corner room, you'll have, call it a server room. Okay. Now in that, you'll have a rack. Within that rack, you will see most of them are like your network switches. And maybe at last you will see one or two servers, one, two, three servers. Rest all, let's say network switch. All these are network switches. Right. Now, here I have cubicles where people are sitting. Correct. So from here to each cubicle, they'll connect to and maybe roof under the carpet. They'll try to run the cables and connect the entire office from this server room. Now, what if the data is trying to leave the room outside? Then it will go to VPN. Let's say this top component is VPN. All these network switches will be interconnected to VPN. And then from outside, your internet connections are internet connection cables are inserted into your VPN device. So if a people are communicating within the office, these switches will help. If people are sending data outside the room or outside the office, it means to say over the internet via VPN, it will go out. Correct? And who will controlling who will be controlling this traffic flow and all? Your network switches. Agree? Now, same thing if I want to replicate onto AWS, let's consider one of the region. Okay. when I say one of the region US East 1. Sorry. In that, as I mentioned yesterday, as we'll have six different buildings. Correct? Within that, what we call it as US hyphen East hyphen 1A 1B 1C 1B 1E 1F. All these are six different buildings. Now imagine let's say two persons are logging into your which portal? This same portal. Okay, so two persons are logging into the same portal. The second person is, let's say, this is another email ID. Okay, so let me go here. This is the account ID. This is a different account, a different person. What is the other account? This is a different account ID. Agree? Now, like this, you will have millions of people who are using AWS services in East US. So everyone want to utilize this data center, or I'll say six data centers collectively, call it as a region. They want to utilize this region to host their services. Let's say I want to host some application. So what kind of application it is? Imagine three-tier application. Three-tier application. What is the three-tier application? Very simple. web application server, DB servers, right? Like this, you'll have three different tiers to host some of your web servers or website. The website is combination of all the three. Now, on web servers, let's say you have two web servers, two application servers, or maybe three application servers with some API integration and all, and the two database servers. Total 7 servers I need to deploy. Okay, this is his requirement. Similarly, he has some other requirement. Maybe he need to deploy 50 servers. Both of them will use the same building, right? In the back end, it might be a same server you both are using, right? From here I'll deploy, from here you will deploy, or I'll deploy from a different account. So both the users might deploy same EC2 instance at a time. Okay, that moment, if in the back end, if one of the hosts is free, both the VMs will go and sit on that. But how they will be restricted communicating among themselves via your VPC. So what is your VPC? VPC is your logical segregation of your resources or a network CIDR provider. Okay, where it will create a logical boundary for your resources. Let's say if Srinivas is trying to deploy these 7 servers, he need to create his own network first. When he create his own network, this is how the network boundary will form. Getting my point? So this is your network boundary. Technically, we call it as, let's say, East US prod VPC1. This is one of the logical boundary in your account. Similarly, I can create another VPC, right? This VPC under this account. Okay? It is actually deployed from this account. And this is deployed from this. And what is the name? Let's say East US Business Unit 1 VPC1. Okay, there it is there, naming convention. Right now, when I say logical boundary, you need to define the IP ranges, like how we did on this situation here. Okay, if you see here, we have allocated this IP range to this. For this is the IP range, and so on. And in the previous discussion also, for office, we have allocated IP range. Similarly, we need to allocate the IP ranges, or technically we call it as assign the CIDRs for these VPCs. So what I will do for this VPC, I'll define a CIDR like 10.10.0.0/16. That means inside that boundary, all the devices which you deploy, they will run with 10.10.6. Fine, no issues. And the same time here in this VPC, I'll give same 10.10.16. Okay, it is possible to have a duplicate ranges because this belongs to customer A, this belongs to Srinivas. Okay, both are two different entities. It is segregated logically, and this is accountable under your account ID. This is accountable under his account, right? Both are two different entities. As long as both of them are running as two different entities, there is no problem in having duplicate IPs. Like you're in your home, your Wi-Fi router will have 192.168.1.0/24. Same in my home also. If I go and check the Wi-Fi router IP configuration, 192.168.1.0/24. So it doesn't mean that both are duplicating. Okay, that is serving in your home and this is serving in my home. So as long as these two are serving isolatedly in respective homes, you can have the same IP range. Similar case here. Okay, now once you create this for this user, this is the architecture. So he need to create 3 subnets. Why you need a 3 subnets? Can anyone tell me why you need a 3 subnets? Why can't you put all the servers in one subnet? Hmm? Any thoughts? Shiva, Cherin, guys, come on. I'm audible? No.
Yeah.
Hmm?
No idea.
Okay, no issues. So let's say I said my IP ranges was this is the total IP range what I have. That means how many IPs you will get? 65,536 IPs in total you will get for this range, right? Now, if I place all these servers in one subnet, let's say the subnet ID is 10.10.0.0/16. Your VPC range, is this. Under this VPC, you're saying subnet. This is also same. That means all the machines will be deployed under this subnet. Now, these two servers, their default nature is from outside, someone is accessing www dot example, this website, right? So this website request will be sent to this web servers. In case these web servers need any sort of application server help in order to execute and get some data, then the request will be sent to application servers. Application servers will send a request to DB servers only if there is any requirement to access the database. Now, can you tell me, is there any requirement that from internet directly application server will respond or directly DB server will respond? From a user perspective, user is accessing over the internet. No, there is no direct requirement as far as website is concerned. Only web servers are responsible to send and receive the traffic, and application and database servers are sitting behind the web server. Now, there is no direct requirement or there is no network requirement for application server to receive something on the internet. Even for database servers to receive something on the internet, it is not really needed. Now, if you keep everything in one subnet, the logic says all the servers within the subnet, they can communicate among themselves. Now, if these two web servers are open to internet, if someone is trying to hack these two servers, they will be able to easily hack all the 7 servers because they're all in the same subnet. Once one server is compromised, they can take over all the rest of the servers from a security standpoint. Right now, technically, there is no requirement that even web servers will not directly talk to DB servers. So the condition is web servers only respond to internet and only talk to application. So application servers only get a response from or get a request from web servers and can request DB for some transactions. So the application servers will only talk to these two people, and DB servers, irrespective of whatever the network that you define, DB servers will only respond to application servers. That's it. Now, why can't you change your thought to keep everything in one subnet and make this as smaller subnets like this? Web subnet 1.
Subnet is something like availability zone or something.
Subnet is something smaller chunk of IPs within the larger chunk. So your VPC is a larger chunk, and I want to cut down into small chunks. Okay, so
Okay.
your subnets are subset of your VPC, technically, if I say.
Okay.
Okay, so 10.1.024. What is the expected number of IPs? 10.10.1.0, comma 1, 2, 3, and 255 are out, because these IPs AWS will take. These IPs AWS will take out, and as a customer, you can use 10.10.4 to 254. So total 251 IPs you can use in this subnet. That means this logical boundary has 251 IPs, and you have two servers. Means after deploying two servers, you will see 249 IPs are free. That means in this boundary, you can still deploy 240 or 250, overall 251 servers here. Okay. Similar case with application servers, right? App subnet 2, 10.10.2.024. Yeah, same thing, 10.10.2.0, 1, 2, 3, and 255 are out, and you can use 10.10.2.4 to 254. That's a usable range here for applications. Similarly, for databases, DB subnet 3, okay, 10.10.3.0/24. Again, here also same funda. 10.10.3.0, 1, 2, 3, 255 are gone, and usable 10.10.3.4 to 254. This is the number of IPs I can use. Like this, if I can create a small chunks, for me, it will be easier to deploy resources in a respective subnets. Okay, now thing is, if you want to deploy the subnet, you can either deploy subnet here. You have an opportunity to deploy the subnet here. Another subnet you can deploy here. Right? As I said, it should be subset of your VPC. Another subnet here. And so on. You can deploy another subnet. Okay. Now, let's consider I'm creating three subnets, right? Let's say web, I will deploy here. Application, I'll deploy here. Databases, I'll deploy. That means you are saying, most I'll deploy web servers in building 1, application servers in building 2, database servers in building 3. Is it possible? Yes, it is possible if you want to. No. I want to deploy web servers here and application servers in a different subnets in 1A only and a DB servers in 1A only, like this. It is also possible. Getting my point? No. I want one web server here, another web server here. Means you need to define another small subnet and define so that you can put two web servers in two different places. Make sense? Right? So this has become your subnetting. So within the logical group, you are creating a subnet. Let me do one thing. I'll just shift them like this. Now, once the subnets are created, you will be able to deploy the servers inside this boundary. Okay, your one server can be, your two servers can be deployed here, another two servers can be deployed here, another two servers can be deployed. Now, the thing is, even though you deploy in building 2, building 3, building 4, your logical boundary is spreaded across all the buildings. Okay, now this server can talk to this server directly without any interaction. Without any interaction in the sense, without any additional configuration and stuff, you will be able to access both the servers among both. You will be able to establish a communication among these two server sites. Okay. Now similar case with this. It is quite possible. Now, if someone is trying to send the data out, like in your home or maybe in this scenario how I'm explaining, internally they'll be able to communicate among themselves via the switches. Now your switch will become VPC, which is your logical software component. Inside you have multiple subnets. Here also you have multiple departments, like in your office I've explained left wing, right wing, and then VIP users, local IT users, and this, that, right? Lot of segregations for each and every people based on the restrictions. I gave them the different subnets. Here, based on my application requirement, I gave the subnets. So in short, your office physical network architecture, if you refer, it is same here, and we call it as we are calling it as VPC. Understood? Yeah. Any questions?
How the different like web tier will communicate with the application tier? How it will communicate different subnets?
Okay, now when you create a logical boundary, this network, this is a kind of a software defined network, SDN. Okay, so you don't have a physical switches connected. It's whatever the red color I marked here is a logical component which is actually spread across all the buildings under your account. This is the one logical boundary. If you create a subnet, by default, these subnets are attached to your VPC. So within the rule is within the VPC, by default, every server will communicate every other server. Clear?
Okay.
That's the kind of configurations what we make. If I want to restrict, no, I don't want to allow web servers to talk to DB servers. Web servers only can talk to app servers. I can put a restrictions. There are ways to control it, but default nature is they will talk to all of them within this boundary.
Web servers can also talk to DB servers because when you said initially you said that like web server only talk to application.
Should. This is the expectation. This,
Okay.
this is the default nature. Okay.
Okay.
Okay. The thought process is if I'm trying to deploy an application, I am expecting this is what my security must be.
Okay.
Okay. Now, in order to achieve that, I need to create a VPC and I need to define the subnets. If I define the subnets, the default nature of these subnets are they can communicate among themselves without any issue. That's a default nature. Now, sorry, boss, I'm expecting this to be a secure manner. So I don't want to allow web servers directly talk to DB servers. Okay, you do your own network configurations. Then you will be able to restrict within the boundaries also. Within the VPC also, you can restrict the traffic, but you have to do some network configuration changes on your side, then it will work. What kind of network changes that I need to make in order to control the traffic, that I will see in the testing.
Okay.
Clear?
Yeah.
So now once these subnets are created, what I'm saying here, I'm just correlating it to your previous explanation. If a data is communicating within the building, your switches and your routers are helping them in routing the data here and there, here and there, here and there. Similarly, inside your VPC, if you are trying to communicate among themselves, so I'm just bear with me. That's a wrong notation, but there is no choice to represent. So it is actually spread across all the subnets again. Sorry, all the regions again within the VPC I'm talking about. Now, what I call it as a route table. Yeah, there will be a route table. This route table will be used by all of these subnets. Okay, how? This route table will be attached to this subnet. This route table will be attached to this subnet. This route table will be attached to this subnet. As long as you are attaching it to a respective subnets, all of them are using the same route table and communicating among themselves. That's the default configuration. Now, if they are talking about within the building, the switches and routers are helping them. If the traffic is going to internet, your VPN and your internet connections came into picture. So now, for me, internet is an outside. Okay, internet is an outside. Now, these servers, they want to send traffic to outside of this data center building or outside of your logical boundary at least, right? So at your boundary level, you need to have a component called, let me bring AWS. See, it will stay here. Okay. So you need to have your internet gateway. This is what we call it as internet gateway. Okay. Now this route table will also route the traffic to internet gateway. Okay. So what happens if people are communicating internally, route table will say you go this side, you come this side, you go this side, you come this side. Sorry, I want to go to internet. Okay, then go this side. Right. So the component who is responsible for sending and receiving data over the internet is your AWS Internet Gateway. Make sense? So far, VPC, your subnets are creating route tables, internet gateway, right? And these two components, when you create a VPC, these two will defaultly create. This is also defaultly created. Now, what I want to do is I'll not stress upon these two components right away, but I will test these two components separately. Okay, how these will function, how we can control all these things, that we will test it separately. Okay, when we talk about security groups and network ACLs. But for now, these four components, okay, this is the hierarchy, how it looks like. Similar case here. You need a route table for sure.
So what this route table will have, so its duty is to route traffic.
It's kind of your four signal traffic controller who sits or who stands over there and controlling that, right? So you go this side, you come this side.
Okay.
Okay. If you're applying a Lehman thought, just apply that. This is kind of your four signal traffic controller.
Okay.
Okay. Now here also subnet 1, I don't know what is their business. They have 50 servers and subnet 2, subnet 3, subnet n. What is subnet n? Last subnet might be just for my reference. Like this, I can create a multiple subnets in this account also. And again, this also need an internet gateway. If somebody from this boundary, they want to send the data to out. Okay, there's no change in the configuration. Like this, they interconnected. Now, if from here it is trying to send some data to internet, okay, now what is this server? What is this server IP? Let's see. If I deploy any server inside, my question is, I can deploy servers inside this web subnet, right? If I deploy any server inside this web subnet, what is the expected IP address? Very simple, 10 dot 10 dot 1 dot, let's say 100. Example. Can I assign this? Yes, you can assign. Okay. And I will deploy another server in application. So 10 dot 10 dot 2 dot 100. Let's see, just an example. And then these two servers should communicate among themselves. Okay, I have two servers. Okay, these two servers, they should communicate among themselves. That is the first testing, what I want to do it today. Right. So for that, what is this account? Let's go to this account 7171. Okay, what is the other account? 324. 324. Okay. So this is my US East one. So what I need to do, VPC, go to VPC. If I go to your VPCs, I do have the VPC player here. Let me delete all of them. Okay, maybe I've created it for some different testing purpose. Okay, so nothing. Similarly, on the other side, if we go to VPC, You have two VPCs. Okay. Delete VPC. Another VPC, just delete it. By default, it's a default VPC, so nothing to worry. Just delete it. Done. So let's focus on 2671. 2671 East US Business Unit 1 VPC 1. Okay. So how to create? Create a VPC where under East US, make sure East US under VPC create East US Business Unit 1 VPC 1. As I said, we will only talk about IPv4. Okay, what is Ipam or something they newly introduced?
Is there any naming convention for this VPC or simply giving?
And you can give your own user-friendly naming conventions.
Okay.
Give me a second. So AWS, Ipam, IP address manager. Okay. So let me see if that is. I think this newly introduced last month also it's not there. Let's see what comes with. There's no IPAM allocated here. So means what here? So whatever the IP ranges or that we talked about just now, as I said, I shared this on the fly, right? So this is just okay. This is the private range. Use this. But what is the significance of that in the backend, right? From where you got? Okay, who gave you this IP? How you are concluding that this I need to use? Right? Why can't we use 10.11, 10.200, 10.60? Why you are using 10.10? Right? So in your AWS, if IP management has become a headache, then your IPAM will. That's what I've seen. It's a new component. Your IPAM will manage the IP address. Okay, within the AWS. Say you have to give. Okay, boss, this is what the ranges I want to use. Now you tell me which is the best one for me. Okay, that way your IPAM will give you IP address. So I'll say, okay, sorry, I don't want to give the choice to AWS. I want to take my choice and I will go with 10.10.0.0/16, which is your CIDR range. So initially also I was, as I mentioned, this is more of IPv4 IP networking. We are not talking about any IPv6 networking here. So none of the IPv6 IPs will be created. No IPv6 CIDR block will be created. Fine. Tenancy. What do you mean by tenancy? You can run your instances on a VPC on a single tenant. Okay, dedicated hardware. Select the dedicated to ensure that instances launched in this VPC are dedicated tenancy instances, regardless of the tenancy attribute specified at launch. Select the default one to ensure that instances launched in the VPC use the tenancy attribute specified in the launch. So means what? If I have default tenancy, so you are also part of regular customers. You will go and sit in your somewhere in the corner wherever the free space is available. Okay. Dedicated tenancy means you are trying to get a dedicated resources or a dedicated network within the AWS East US, and you will be treated like a VIP. Okay, maybe they'll reserve the front seat for you. That's a simple layman definition, I would say. Okay, so I'll go with the default tenancy. So it go and create somewhere within the East US one. Now create a VPC. Right? If you see, the VPC ID will be created. When you create a VPC, VPC ID will be created, and you see DNS host names, DNS resolutions are enabled, DNS host names are disabled. Default tenancy, it defaultly created 3 components. In fact, 4 components. Okay, so one component is DSCP option set that we will talk about later. Another component is your one route table. If I go back to my diagram, this will be created. These two will be defaultly created. Getting my point? So I'm just keeping that aside. I'm talking about this. Now, default option set is created, and then route table, network ACL, and also security group is also created. If you go here, yeah, here is 286 is the VPC. Another, the one security group is created. Go to your VPC. Your VPC ID is 286. Right. So is it a default VPC? No, it's a manual user created VPC. What is the IP range? This is the IP range. Who is the owner of this particular VPC? I'm the owner of this particular VPC. Okay. So what is the IP ranges? Only IPv4 I'm using. It is more of 10.10.00/16. Boss, I want to reduce, I want to increase. Now you do it before you deploy something. If I want to increase or if you want to decrease, (10.20.00/16). Save. This has become 65,000 plus 65,000. How many? 1,30,000 IPs. That is a logical boundary. Oh, sorry, I don't want to use this. Okay, then /24. That is also possible. Okay, 65,000 plus 250. 65,536 plus 256. Okay, that's the boundary. So in short, your logical boundary is not a fixed value. Okay, so for this is what I have decided. Okay, for this is what I have decided. So your VPC will run on this range. That's it. It's a logical definition what we are trying to associate with the VPC. Right. Flow logs and tags that we will talk about later. Now let's understand the basic hierarchy. So it's been assigned. Now what I need to do, I'll simply go to actions, edit DNS host names, enable the DNS host names, save. So what is the meaning of that? Whenever there is a server deployed, it will automatically get one host name, so that over the internet, you will be able to access them with the DNS name also. This is enabled. Now, once this is done, you need to create a subnets. What kind of subnets that you need to create? Create under VPC only. Right? This is whatever the subnet that you're trying to create, it is subset of your VPC. Alone, you can't create any subnets. Make sense? So, East US prod subnet 1. In which building you want to create? Now tell me. 1A, B, C, D, E, F. Where you want to create? I don't have any preference. You take the choice. 10.10.1.024. Okay. You want to add one more subnet? Yes, boss, I want to add one more subnet. East US prod subnet 2. This time I have a preference. I want to deploy it in building 1. Okay. And what is IP range? 10.10.2.024. Create, or let me add one more subnet. East US prod with subnet 3. No preference again. 10.10.200.024, which is also possible because your first 2 octets are not changing, and on the top it's /16, so you can use any IP range within that second and third octet. Done. So you see 3 subnets were created. If you click on any subnet, you'll see a subnet ID is again created. How many IPs I can use? If I go back to my discussion here, 254, total 251 IPs you can use. Okay, 251 IPs, no IPv6. I haven't mentioned its choice is given to Azure itself. Then, sorry, choice is given to your AWS itself. So here it is deployed in your 1D building number 4, and availability zone ID US East 1, availability zone 4. Okay, it's a fourth one, D or a 4, whatever the naming notation that we want to keep it, right? So network border group, okay, under which network it is functioning? US network. US East 1 is having one network border, physical network border. Okay, within that physical network border, you have one logical network border. Physical network border will be maintained by AWS, and logical network boundary or a border will be maintained by end customer. And the route table is created, network ACL is created. Is it a default subnet? No, it is not a default VPC and a default subnet, right? Auto assign public IPs. Auto assign public IPs. You want to assign a public IP? Here we're talking about private IP only. Here we're talking about private IP only. Okay, so it will not assign auto public IP. If you want, you can enable subnet settings, right? Enable auto assign public IPs, that you can enable it, but I don't want to do that at subnet level. I'll keep it disabled. Maybe in the down the line when we are doing some testing, that time we will see. And auto assign IPv6, I don't have any IPv6, so let's forget about E6. Auto assign customer owned IPv4 addresses. No, will not assign. Customer owned IP pools and all, there's nothing as such, right? So, and your outpost ID and CIDR reservations, IPv6 CIDR reservation, there's nothing as such. DNS is disabled, and DNS A records are disabled. Host name type is IP name, means host name. Every server will be allocated with some name that will be your IP address only. DNS 64, sorry, it's disabled. Route table by default there is one route table which is created here. Network ACL by default there's one network ACL 249 which is created here. So I'm not bothering about these two things right now, but this how subnet settings looks like. Now another important thing is ARN. ARN means Azure Resource Number. Identifier, unique identification of your resources. Subnet ID is there, but this particular resource, this is one component. How I will uniquely identify ARN reference. Okay, so if you want to understand more, what is ARN in AWS? Azure resource names uniquely identify AWS resources. We require an ARN when you need to specify resources ambiguously across all the AWS, such as IAM policies, databases, this, that, everywhere. So you have a, let's say 3,000, 4,000 components deployed across AWS account. This is your unique identifier of your resources. Okay, that is associated with ARN, Azure resource number, name or number. Okay, it's technically Azure resource name. Sorry, AWS resource name. Your AWS. It is related to EC2. Okay, US East 1, and this is your account ID. Under this account, subnet. What is the subnet ID? This is whole identification of your resources. Let's go to the VPC and see. VPC don't have any ARN IDs as such. Okay, it's a logical boundary, and your VPC ID is the one unique tracking for your VPC. Right. So these two things are clear. I've created 3 subnets. Every subnet has 251 IPs boundary. 2 of them are deployed in D, where I put as no choice for me, and one is deployed in A, but availability zone is showing as 6. It's fine. Okay, whenever the failure is happening, these two, your A and 6, ideally A is equal to AZ1. That is the expectation. Maybe they have done the failovers in the backend in the past, so that's why those numbers are jumbled. Okay, now default route table, default network ACL, and rest all this what I've discussed. Now let's go to route table. By default, you got one route table. Okay, fine. Let's keep that aside. I don't want to touch that route table. Okay, I want to create my own route table saying East US production business unit 1 VPC1 underscore route table 1. Okay, under this VPC, this is my custom route table. What is the VPC? This is the VPC. Create a route table. Again, you will see a route table ID has been created. Again, unique identification under the VPC. Is it a main route table? No, this is not a main route table because we have another route table which is sitting aside that I am not using. Okay. Give me one second. Routes 10. This is your whole IP range, right? So who all are part of this route table? Subnet associations. I have 3 subnets which are not part of this route table. So what I'll do, edit subnet association, subnet 1, 2, 3, save. All the 3 are now part of this route table. That means these 3 subnets will listen to the instructions given by this route table. What kind of instructions this route table will give? By default, no instructions. By default, within this boundary, everybody can talk to every other person. So that is the default route. Now, let's go to the internet gateway. Okay, internet gateway is not created by default. Create an internet gateway and East US prod business unit 1 VPC1 underscore IGW1. Okay, under this business unit, this is VPC1. Under your VPC1, it's an internet gateway. Okay, create. You don't have any VPC, right? So internet gateway ID is created. It is saying VPC is created. You need to attach it to someone. So who is that someone? Attach it to my VPC. It is now attached to VPC. Okay, so now go back to the route table. This is the route table I'm talking about. This is default one. I'll say default. Don't use. Clear? So this is the route table. I'll go to edit routes, add a route saying everything 0.0.0.0/0 means in this boundary, everything please route to internet gateway. Internally they are communicating, it's fine, but if you are sending something somewhere, everything please send it via internet gateway. Okay, how to? So everything you can send it to multiple destinations like this. Local is already there. Okay, it is local network. It is local communication is already established. So apart from local, you have these many destinations from this boundary. Okay, so our boundary is your Internet Gateway. What is the Internet Gateway? 854. So if you see East West Prod Business Unit 1, VPC 1, IGW 1. Okay, this is the right one. See. Now what I'm doing from these three subnets, everything I'm sending it to Internet Gateway. That's the routing. Sorry, boss, I have some other VPC. I want to send it to the different VPC. So how to send? That's a different story that we will see later on. But for now, everything is sending it to internet. And your internet gateway is done. Route tables are done. Network ACLs. Network ACLs. Let me add some description to it. East US, prod, VPC, East US, prod, business unit 1, VPC 1, NACL 1, network ACL 1. It's a default one. So for now, all inbound is allowed, all outbound is allowed. Then no worries. So leave it as it is, no modifications. Network ACL, after that security group. Okay. So East US, prod, business unit 1, VPC 1, yes, security group 1. Under VPC 1, this is the security group, default security group. Inbound rules. Inbound traffic is coming. Outbound traffic is going to everywhere. Inbound also, let me make it as everywhere. Edit. So I'll explain this later on leisurely, right? So all the traffic, I'm saying anywhere, and just delete the old rule and save it. So
when security group is created by default, this inbound and outbound rules also will be there by default, right?
Yes, everything will be there by default. You need to customize it based on your need.
Okay.
Okay. So what I customized here is I'm allowing all the inbound, I'm allowing all the outbound. That is the customization I did. 0000/0 means allow everything blindly.
Okay.
Okay. So far my network has been set up properly. Okay, where 2671 account 2671 is completed. Then what about this? This is a different customer, a different account altogether. You have to do it by your own. Okay, this is a different 8324. 8324. Okay. Can I create similar sort of thing here? Yes, you can create. Create East US prod VPC 1. What is the IP range? 10.10.00/16. Default tenancy, yes. Create. And it has a different VPC ID 33D. Okay, so 286. This is different. So let's go to the subnets and see. Subnets are different subnet IDs. Now in here also, what we will do, edit DNS host names, enable. That's one option in VPC. Let us set subnets. What is the subnet I like to create? Web subnet 1 in 1A 10.10.1.024. Add subnet app subnet 2 1B 10.10.2.024 and DB subnet 3 1C 10.10.3.024. Okay, so let's check the diagram. 1A, just sorry, This for my reference. I'll move it to 1A, 1B, 1C like this. Okay, I can change it. Anyway, I haven't clicked it, right? So it's very simple. So let me make it as 1B. Let me make it as 1C. Let me make it as 1D. That's it, done. So in line with your diagram. I don't want to change this diagram a little bit, but those ranges were adjusted here. So create. Done. You see again 3 different subnet IDs created uniquely. If I take any subnet, your ARN ID is changed, right? So your account ID under that, this is your subnet. This is your unique identification within your account. And if you take a look at IP ranges are same on both sides. Same IP range, but this works because both are in 2 different accounts. Both are in 2 different customer places, but both are in a physically on a same building. What we need to understand here is, right? I'm not going to create a route table internet gateway and all that. We will test it tomorrow, right? But okay, let's create and keep it ready so that tomorrow our testing time will be minimized. So subnets are created. Let's go to internet gateway, create East US prod VPC1 underscore internet gateway. Create an internet gateway, attach VPC1. Okay, this is attached. Now go to the route table. Previously I said I don't want to use the default route table, and here I'm saying I want to use the default route table. So East US prod VPC1 route table 1. Go here, subnet associations, edit. How many subnets you want to add? All these 3 subnets will be part of my route table. Okay, and routes, by default there's one route. Rest all the routes where you want to send it across, everything to internet gateway, your VPC1 IGW on this account. This is kind of sorted again. So your route table is now created. It's default route table. I'm not using any additional route table here. So network ACL, it's already created by default. So East US prod VPC1 NACL. Security group, it's already created. So East US prod VPC1 security group. Inbound, edit, add all traffic, anywhere, delete, and then save. So both the accounts were now configured properly with the IPs. Now, what else is pending here in terms of testing? Let me go back to the diagram. I want to put 1 or 2 VMs here, one or 2 VMs here, maybe 2 virtual machines here, and I want to put 2 virtual machines here. This is different account and this is different account. I want to deploy 4 servers tomorrow and I want to test it from outside. Okay, so test it from outside means, let's say from my home, I want to access via internet only. Via internet, the traffic will go, and I want to access these 2 servers, and I want to access these 2 servers also. Okay, so let's try and test that tomorrow, and then after that, we'll see further what all the components that we can add on top of it, right? And we will discuss that further tomorrow. So, in brief, this is what we did shortly today. So yeah, if you have any questions, I can help you with. No, Siva, Washeen, Shareen.
Yes, yeah, I can understand.
Okay.
Yes, it's clear, sir.
No issues. Yeah.
No questions, but can you place this recording in that group or something?
No. Yesterday you might have received emails. So everyone, you might have received the emails. Okay.
Okay.
So let me stop the video recording first.